Hello, everyone, and thank you for joining this webinar, Understanding Global Internet Connectivity Trends and Insights, in collaboration between Capacity Media, Kentik, and Orange International Carriers. My name is Saf Malik. I'm a reporter at Capacity Media, and I'll be hosting this webinar. I would like to introduce Doug Midori, Director of Internet Analysis at Kentik, and Sonia Misuel, IP Transit Product Manager at Orange International Carriers. Over the first 45 minutes, Doug and Sonia will discuss events affecting global connectivity, BGP monitoring, and reveal how Orange International Carriers keeps an eye on its market share and competitive activity. We'll then have time for a 15-minute Q&A at the end, so please send questions throughout. Questions will be submitted anonymously and your name will not be mentioned. In the unlikely event that you experience any technical difficulties, please just refresh your window and this should correct it. I will now hand over to Sonia Misuel from Orange International Carriers and Doug Midori from Kentik. Take it away, guys.
Hello, hi everyone. So I'm Sonia Misuel. I am working at Orange International Carriers within marketing team as product manager, and I am in charge of IP transit products, so the ISN, the IS number 5511. I am based in Paris, and I am very glad today to share this webinar with Doug, this webinar between Kentik and Orange. So in few words, I'm going to present, to start with an introduction and to present the Orange International Carriers. Orange International Carriers is part of Orange Wholesale. A new entity has been created beginning of the year in order to support the ambition of the group in wholesale and infrastructures. Orange International Carriers provide international connectivity to carriers and to international players worldwide. We have a 3 line of solution. The first one is voice, and we are the first wholesaler in terms of volume. The second one is mobile services with a full range of services and 800 roaming agreements. And finally, the subject of today, data. So we have also a full range of solutions, starting with submarine cables and 450,000 kilometers of submarine cable, terrestrial capacity. So the two products are, of transmission are IPL and EVPL. We have also a CDN solution and the IP transit, the subject of today. So this was for the introduction of Orange International Carriers. So just as a reminder on IP transit, so you all know that is an internet connectivity solution, and our mission is to connect content provider that send traffic and internal service provider that receive traffic in a high quality IP network. And so the end user can benefit from the best possible digital experience. So end user are not our final customers, but they are key in the story of IP transit. So it can be you and me watching content on our laptop, but also and more enterprise with their cloud usage that they use internet connectivity for their cloud usage. So regarding 5511, so we are a tier 1 IP transit provider. So within the 15 tier 1 IP transit provider worldwide. So it means that we have an international footprint, an international presence. We don't buy IP transit to other suppliers. And we give access connecting to 5511, give access to all the internet routes with only maximum 1 hop of network. So this is key for internet connectivity to have access to tier 1 providers. In a ranking, in a Kentik ranking, so we are in a top 10 of IP transit providers. So 8 in April and in May. We are 6 in Europe and 3rd in West Africa. So I mentioned these two regions, Europe and West Africa, because they are key in our footprint. But globally, we have more than 200 POPs with a main presence in Europe and Africa. And what is important is that we would like to have local presence for regional and international traffic. Today, we have more than 300 customers. So 1/3 of our customers are content providers that send traffic. 2/3 of customers are internet service providers that receive traffics, and all the Orange affiliates are connected to 5511 for their international connectivity. In terms of evolution of our network, so we have launched last year 400 gig ports. So this is key for the increase of traffic. So it was available in Paris and Marseille. End of the semester, we will be available in Spain, London, and Amsterdam too. And step by step on all the big POP point of presence. We have also deployed implement RPKI filtering and validation on all our routers. So RPKI are fully deployed on all our networks. The SLA are key for our quality of service. So we have a high level of SLA on latency, packet loss, and availability. And we are very proud to have an award last year for the best data global wholesale carriers. So it was for last year. So I give the floor to Duke.
All right, thank you, Sonia. So at this point, I'm going to talk a little about a product that that we have released a little over a year ago from Kentik that's used by Orange, among other multinational carriers, and it's called Kentik Market Intelligence. And this is a SaaS business intelligence tool for the transit market. And I'll go through a couple of the use cases. The first one being those use cases being marketing, sales, and planning. I'll talk about that in a minute. But in general, this is a SaaS tool that's entirely based on the processing of BGP data. The way it works is that every 6 hours, this updates. It reads in hundreds of full global BGP tables. It geolocates every prefix, figures out where in the world it is, looks at the AS paths, classifies the relationships, and builds basically a global model of the internet and the transit market. It then computes scores based on those prefixes, which we use to do the rankings, and those scores are based on address space size. We have some documentation that I can direct you to get into more details of how exactly this works. But basically, it's a combination of AS classification, geolocation, and computing scores. So how does somebody then, once you had a model of how the transit markets of every country work, how do you make use of that for your business? So as we mentioned, there's numerous rankings based on different geographies, whether you're looking at a global ranking, ranking within a continent, a subcontinent, country. We basically, each one of those would take the prefixes that geolocate to those geographic scopes, calculate their scores, and then rank the transit for those carriers handling traffic going into those places. And it is all the prefixes in the customer cone. So if a network has a customer who also has another customer, who also has another customer. Any of those prefixes gets the scores from those prefixes get added into that score. Another use case, probably one of the most important, is in sales prospecting. And so the way this gets used is that sales teams will take a country, typically, we will refer to it as a market, and figure out who are the players there. If you have an AS, if a company has an AS, that means they're transiting traffic, and therefore they are eligible to be getting transit from a transit provider. It's very helpful to be able to navigate around in a market and understand who are the customers of your competitors, who are your prospects currently getting service from, and then getting alerted on those changes as they occur. So you can keep tabs on a market, keep tabs on a competitor, and at times we've seen customers keep tabs on their own customers, just to make sure that they are aware of an existing customer perhaps diversifying away from the transit they're currently selling. So there's a lot of key insights here. We've also, based on feedback that we got from during our development of this phase, especially for this sales prospecting section, that one use case was to identify singly homed customers of a competitor, because in those cases, it may be possible for a sales team to be an additive transit option for a customer instead of having to displace an existing transit relationship. Again, we've taken a lot of feedback from the sales folks from these network service providers and tried to build that into the tool so this would accommodate their workflow. And lastly, we also this style of tool over the years has been used by folks in network planning. So this is network architecture, peering coordinators, people who are interested in having general knowledge easy at their fingertips to understand who are the players in a country, who are they buying service from, how is that changing, and this helps their strategy. Or for cloud providers, if they're going into a new geography, again, to understand who are the transit providers, how would they achieve true transit diversity. There may be 5 options of transit in the city that they're trying to establish a POP in. However, two of the 5 actually buy transit from a third, so that's not really very diverse. You'd like to have as diverse a path with a mind towards resilience as you could possibly attain. This is a very easy way to answer questions like that. And I think Sonia is going to talk a little about how Orange uses this tool.
Yes, so how we use KMI within Orange. First is for the ranking, because our customers are looking at the ranking, and so we need to know our position and the position of our competitors. So we use it because our customers use it, and for all the competition analysis. This is the first step. The second step is for customer knowledge. So we know our customer, where they are connected, their traffic. But with Kentik, we have a view also on their suppliers, the position that we have between the supplier of our customers, their peer, their customer of our customers. So it's a very helpful insight for our customer knowledge and for to improve our customer relation. And the last point is for prospection, as Doug mentioned, to identify our prospect, but also the region, the regional market potential, the region that where we need to put a new point of presence. So it's part of a study for new point of presence. So it's why we use KMI. And then, so I'm just going to focus on 3 trends that we see on the IP transit market. So the first one is the traffic forecast. So IP transit traffic returns to pre-COVID level. So after a 2022 years, when we see a slowdown of a growth of traffic. But we have very high peak in 2021 and 2020 due to COVID crisis. So now with the first months of 2023, it seems that we will be back at a yearly growth between 25 and 30% of yearly growth. This for the traffic, so it's a good news. For regional hubs, so we would like to focus on these regional connectivity hubs. So we have presence in FLAP, Frankfurt, London, Amsterdam, and Paris. But now we have more regional connectivity hub. It started with Marseille, that is used to deliver traffic for Africa and Middle East customers. But we have also now, and more important in our footprint, South Africa with Johannesburg POP and Lagos POP, that are regional connectivity hub for Africa. So it allows us to deliver local traffic, regional traffic, and international traffic in only one solution. So it's very helpful and improve the quality of service for our customers and the quality of experience for the end users. So this is the trends with regional hubs. And then what I mentioned at the beginning is critical business. So we see that more with cloud, the development of cloud usage on internet traffic, internet connectivity, we see more and more critical business on our network. So it's why we have two solutions for this critical business. The first one is a solution that we call Advanced Cloud Access. So this solution is within IP transit capacity and is a special configuration, BGP configuration based on a class of service that allow to reach several multi-cloud providers, and with the highest quality of service and highest SLA. So this is key for enterprise that use internet connectivity to reach cloud. And the second point is DDoS protection. So we have more and more, it's well known, DDoS attack everywhere. So is why we have decided to increase the number of TMS platforms. So it's the cleaning machine for DDoS. And we have platform in Europe, in US, and now in South Africa, and also in Singapore. So it allows us to clean the traffic and to detect attack and clean the traffic more quickly, and it gives to our customer highest quality and highest experience on IP transit 5511. So this was for the trend on the IP transit market. I give you the floor, Duke.
Okay. So at this point, I'm going to shift a little over to discussing RPKI. So as you may or may not know, a lot of the time I spend during my day is doing analysis of BGP, Border Gateway Protocol. This is a key part to how the internet operates, and it's a big part of my job. And so one of the things that has been plaguing routing since its inception is routing security. It's a very hard thing to get to deploy a distributed security mechanism to the global internet, where you have to have thousands of entities all decide to do a thing. Having said that, there's some progress to report, and so I'd like to take a moment to go through that. So RPKI ROV specifically, this is Route Origin Validation, the application that rides on the RPKI infrastructure, is presently our best defense against hijacks due to typos and leaks, the accidental type scenarios. And it's doing its job if it can determine that a BGP route is invalid and suppress its circulation. And in order to do that, to reject a invalid route, it needs to, two things have to happen. Number one, the owners of the IP address space have to create a ROA, that's a route origin authorization. They can go into their um, there's a portal in their RIR. There's a way to do this. That's kind of the easy step. One that's a little harder is then networks have to configure their routers, their border routers, to reject invalids. So they have to be able to evaluate on the fly as announcements come to those routers, which ones are invalid based on the latest RPKI information, and then drop those routes. And so there's these two steps, and we'll talk a little about each one, where we're at. So on this graph is a little hard to see, but this is a graph created by NIST, which is a U.S. Federal agency that studies technical standards of lots of different things, but they also have an office that focuses specifically on routing security, and a lot of their work is around RPKI, around the standards. And they have a website here where they track a number of stats, and they have a lot of temporal analysis like this, where you can see through time what's the trend line. And there's a very positive trend line here that's showing this yellow line are routes that don't have ROAs, that are in the global routing table. This is all for V4, but if you were to look at V6, it looks very similar. And then the green line is the routes with valid ROAs, and that is on a steady clip going up. And I was just working on some math yesterday to estimate when these lines are going to cross, and it looks like we have about a year before the green line will overtake the yellow. But and then on the bottom there's a red line of the persistent invalid routes. These are typically due to misconfigurations, and at any given time there's a handful of these misconfigured routes that are invalid. Unfortunately, with any new technology, there's expected to be some of this that does cause some problems for some folks, and they need to go and fix typically the ROAs that they set up. But it's a very small amount. Anyway, so this is the counts of ROAs are going up, but I think this actually understates, based on analysis I did last year with Job Snijders, who's one of the world's leading experts on RPKI, on where we stand. It's actually even better than what this graph would have you believe. So what I did was I took Kentik is known as a NetFlow analysis platform. That is one of the main tools that people come to Kentik for. And so with that, we have this very large store, maybe one of the largest in the world, of aggregate NetFlow, of just records of traffic traversing the internet. And so I took that data. I had a hunch that things might be better than those stats, those previous stats showed, and ran the numbers. And it is the case that if we went bits per second, just volume of traffic going to routes with valid ROAs, it's a lot higher than the count of routes. And the logic here is that not every BGP route is created equal. And some are going to carry a lot more traffic than others. And given the fact, when you dissect the numbers, as I did in the analysis last year, why is it the case that we may have only 43% of BGP routes with ROAs, but 60, in this case, it's almost 64% of traffic is going to routes with valid ROAs? It's because of a couple things. One, content providers. There's been a lot of RPKI deployment in major content providers. Amazon, Google, Cloudflare, Akamai, these are big networks that push an enormous amount of traffic. And when they when they deploy RPKI, then they are punching above their weight as far as the counts of prefixes. And then also the U.S. is similar to a number of other countries, including France and Germany. The U.S., so we have Charter Spectrum and Comcast have also had RPKI deployments. They are our major access level networks in the United States, and so they are also pushing an enormous amount of traffic. So that's why the traffic stats are actually higher than the just BGP alone stats. And I ran the numbers for France, as we're on a call with Orange. In this case, it's actually about the same as far as like how many BGP routes, how many that geolocate to France, or sorry, it's actually IP space. I got this off the RipeStat website. It's about 74% of the IP address space in France is covered with valid ROAs. And then when I look at the net flow, it ends up being about 74% of bits per second going to France based on, again, our aggregate net flow. Usually it's not that way. Usually there's like it's like I said, like in the United States, we have a smaller percentage of routes and a higher percentage of traffic. And, I would just say that add that, we can also see where is the biggest destination of valid routes. And it's, this is AS 3215, which is Orange's domestic network within France. And their RPKI deployment pushes up the numbers for France. It's the largest destination for what I'm calling valid traffic. That's traffic to a route that has a valid ROA. So that's the good news on the ROA creation. But if nobody rejects routes, then the ROA creation doesn't accomplish anything. So at the end of the day, you need networks that are going to be dropping routes that dropping those invalids so that we limit the propagation of invalid routes. And so this was a study I did again last year, and I may publish something up to date on something with more recent data. But in this graph, the V4 and V6 look very similar. You have a spike in the, so the x-axis on these are just how many BGP sources see a route, and the y-axis is the count of the routes. So you can see a surge around, like V4, around 300. This is just using some route views data, around 300 BGP sources where there's that's basically globally routed. Routes that are globally routed, there's a peak there. And those that are RPKI not found, those are routes without ROAs. And valid, they both look very similar because these are both routes that don't get filtered, so they have a similar profile of propagation. But when you drop down to the green here, where these are routes that are invalid, if a route becomes invalid, its propagation is cut by a half or 2/3, and this is the system working, where we're without anyone's intervention, an invalid route doesn't have the same propagation. And in the event of an origination leak or some other routing mishap, that will serve us well, because those bad routes won't circulate as far. And a lot of it has to do with the international carriers, Orange being one of them, that is rejecting invalids. And I would just mention also here's an actual war story of something like this that we had picked up, where PTCL, this is the incumbent of Pakistan, on January 6th began announcing this 90/24. I think this is probably some sort of an internal route that they use. They are accidentally announcing it out to the world, and this is a more specific of a /17 announced by 3215, again, Orange network in France for domestic network. So since Orange had a ROA, the RPKI system limited the propagation. So in this graphic here, we're looking at a BGP visualization out of Kentik. We're seeing that only about 25% of the BGP sources saw this more specific. Had RPKI not been there, it'd probably be at 100%. We would expect to see a more specific be globally adopted. And any of Orange's customers who had been using that address space to work would probably experience a disruption at that time. In this case, RPKI kept the route from circulating, and had if we had one more international carrier dropping invalids, it probably would have been 1% or maybe 0. Maybe it never would have left Pakistan. And we're almost there with the international carriers, the big backbone carriers like Orange dropping invalids. There's only a couple of holdouts, and I think they're working on it now. So maybe in a year, this kind of thing, we wouldn't even know it would happen. But I think it's important to point out these little success stories, because these are happening every day, and they don't get the same headlines that some of the big routing incidents occur that occur. So in this case, I picked it up in my analytics analysis. We alerted the Orange team. They contacted PTCL, and the route was removed. They fixed this, but I guess the bottom line though is that this is just an actual example. Again, they happen every day of routes that are invalid routes that are getting filtered. So that is a little talk about Kentik market intelligence, and then a little discussion around BGP RPKI. And I think we have some time for some questions.
Yes, thank you, Doug and Sonia, for the insightful presentation. We have a couple of questions here, so I think we're going to start with you, Doug. A recent Cloudflare analysis showed a very small number of ASIS reject RPKI invalid routes. Your analysis suggests that there's a lot of rejection of RPKI invalid routes. How do you reconcile those differing conclusions?
Yeah, so there's a lot of people, a lot of different entities trying to answer the question of who is rejecting invalids, and this is harder. Obviously, the other side of it, who's created ROAs, that's pretty straightforward for anyone to go and find and see. The other side, you have to come up with some sort of a trick to, in general, to figure out who is rejecting invalid. So Cloudflare announced an invalid route and found that a very small percentage of the ASs are rejecting, and I think that doesn't surprise me. It makes a lot of sense. And so that I don't think they're in conflict with my analysis, because Cloudflare is a special network. So Cloudflare has got thousands and thousands of peering relationships, and typically those peering relationships they often don't get filtered. If a highly peered content provider leaks a route, it's likely to do a lot of damage, since they're right. There will be very few networks that reject those routes. What I was showing was that as routes go across the internet and go through we call it the DFC or the TFC, transit-free zone. This is the going across the backbone carriers, that those won't propagate as far. And in my experience, most leaks come in that form, where they're barfed out to the whole internet, and so then these international carriers like Orange, when they're rejecting routes, they're actually providing a service to their customers, because even if not all the ones below, downstream of them reject, it'll have been rejected before it got to them. And that there's a lot of benefit in that, and I think that's more applicable to how routing leaks work. The way that Cloudflare did it, by directly announcing it to all these networks, kind of circumvents that, and so you wouldn't have the benefit of these backbone carriers rejecting invalids on behalf of their customers. So I have a more optimistic view. I think their analysis is correct. The way I interpret it is that we're in a better state than that their conclusions would let you believe.
Mm-hmm. We'll stay with you for this next one, Doug.
Okay.
There's been a couple of attacks against cryptocurrency exchanges that employed BGP hijacks on routes with ROAs. Why wasn't RPKI able to block these hijacks?
Yeah, so in the space of routing security, I think it's important to keep perspective on the problem. It is a really difficult problem, and there is a spectrum of, if you will, of problems. On one end, I sometimes say these are like the bonehead areas of just fat finger typos. We have a lot of those affecting the internet. And then the other end of that spectrum is a determined adversary, where you have someone who is very familiar with those security mechanisms that are deployed, and will work around them. And so there have been a few cases in recent times of those determined adversaries going after cryptocurrency exchanges and being able to circumvent the routing security that's been deployed. I think it's important to note that I think the folks that are pushing for RPKI ROV tried to use very careful language to not assert that this solves all route hijack problems. One can forge an AS in an AS path and defeat RPKI ROV. So mainly the benefit is for accidental things such as that PTCL hijack leak of Orange. Those are the things that it'll help with. And to get to the handle that determined adversary scenario, then we have to deploy additional mechanisms. And in the for the cryptocurrency thing, where people these actors are forging AS paths, then there is a mechanism that's proposed, not fielded yet, called BGP-SEC that would need to be used to verify that the origin is who they say they are. For the present time, we don't have a solution, and we have to rely on other security mechanisms to try to defeat those. But that's RPKI ROV does not solve all of routing security. Is where we're at right now.
Sonia, jumping over to you for this one. How does Orange ensure the quality of service and security of its IP transit service on the AS5511?
Yes, so first is, I think, with a POP, so our footprint. So we have a strategy to deploy POP closer to our customers and to be everywhere in the world. So this is the first step. Second point is the backbone, that we monitor our backbone capacity to be sure that is always sized to for customer traffic. And also in our architecture, we take care of security and redundancy of our backbone. So this is the second point. And the third point is the security. So with RPKI deployment that we have done, and also some option as a DDoS protection or blackcalling that we offer to our customers to have a better security on our network.
And moving back over to you, Doug. So there are a number of free tools that report ASN rankings and BGP adjacencies. Why doesn't someone just use those tools instead of KMI?
Yeah, that's a good question. If I were on the opposite side of this call, I might ask the same thing. So I sometimes, like we're talking about, like BGP to HE.net is a very popular reference tool that processes BGP data and tries to present a number of things. There is a difference between the free tools, and I guess the best way to do that is to contact us, schedule a demo. We can show you, but just I can run through the features. So a lot of those tools will not do geographic, change the view based on geographies. There are a few different types of rankings that we do. Like one is we try to separate retail from backbone. So retail being ASs that are actually originating address space in that geography versus backbones or wholesale carriers that are carrying that traffic. And then probably the biggest thing is we call it insights here, where there are changes. So I mentioned that this is getting recomputed every 6 hours. And there is a way to subscribe to the things that you care about. So each network has got its own, thinking a little bit more on the sales work use case. You've got your own objectives of the markets that you're trying to keep track of. You probably want to keep track of your own network, make sure there's nothing weird that pops up here. But you can subscribe to things that you care about. So those are geographies and also ASs, networks you'd like to know. And then when it's a highly configurable method of subscribing to insights of, if they gain or lose customers or transit providers, they gain or lose in ranking if the address space is changing. So a lot of times you'll have cases where the amount of routes that are going across an edge changes radically, even if the edge was there before and it is there after. So it isn't a new edge, but it's changed materially. So those are things that you can subscribe to and keep tabs on things. And then at the end of the day, there's a company standing behind all of this. There's a lot of functionality that I just went through. And then also I've been doing this for a long time, where we have customers, they see something in the in the product they want to ask, and we try to capture everything we can. Routing is a highly dimensional thing, so there are occasionally things that we can't you may need to reach out, and I'm happy to look into it. This is kind of what I do for a living, and so I don't know that you're going to get that kind of level of service with some of the free tools. But again, the best way to test this out is to give me a call and let's talk about it. I can show you and give somebody a tour, and you can decide for yourself.
Thanks, Doug. And just to our viewers, please send in your questions. Another one for you, Doug, actually. Does Kentik Market Intelligence use active or passive measurements? And how can they detect from the pairing relation besides transit?
Okay, yeah, from Arif, I know Arif. So we do not do any active or, well, I mean, passive measurement, I would classify BGP as passive measurement. Active measurement, I would think like we're running trace routes or pings or something like that, so we can determine things like latency and packet loss, jitter, or those kind of things. KMI does not do that. We've had some discussions of maybe doing that in the future. We'd have to invent some sort of a benchmark measure of how do you where do you measure from would be a question. Those mentioned highly dimensional. This gets really highly dimensional of what networks you're crossing to figure out what's a good latency to get to to what. Like there's so many things in the internet. So that would be so right now it does not have that built in. We separately sell, we call it synthetics monitoring, just if performance is a concern or something you want to keep tabs on. It's not built into the product. And then the second part of that is determining the difference between transit and peering. So yeah, there's a model. I mean, this is based on the Valley Free. I'm sure Arif is familiar with this idea that in an AS path, you can infer a lot of the business relationships between the AS adjacencies. So I would say, again, from having done this for almost 14 years now, probably 90% are easy. They're like the vast majority are super easy to classify, and then those last few percentage, it keeps getting harder and harder. You get odder and odder unusual cases, and those are cases where we start to bring in. We basically have it's a machine learning. I don't want to call it AI, but it's a machine learning thing where we'll go back and look at the previous classifications, learn from them, their attributes, apply those to the next batch, and then we bring in things like BGP communities are helpful to carriers are often noting who are their peers, who are their transit providers. I would say communities are not always correct. Sometimes there's some housekeeping where they are out of date and need to be updated. But so that's a weaker metric, but that is another piece that's that is used in that classification. Again, we have some of this written up, and I'm happy to go into more detail. I love talking about this stuff, so you're doing me a favor if you want to talk to me for an hour about this. But I think that's probably enough for now.
And staying with Arif, he has a question for Sonia too. From an enterprise customer perspective, since there's a clear migration to cloud, so more and more traffic is coming from main hyperscaler ASEs, how can they differentiate and analyze their customer demand comparing the wholesale customer?
Yes, so it's why we have created a solution that we call Advanced Cloud Access. So I just presented earlier. It's a solution based on a class of service and a specific configuration. So we need to know the IP addresses of the customers and which cloud providers you would like to reach. And then, so on the IP transit install capacity, we can have dedicated capacity for this cloud usage. So it gives us an improved or guarantee quality of service with higher lower latency, lower packet loss, and then also with this solution we commit on jitter. So it's a way for enterprise to use IP transit and to have only one access for their cloud access and all the other access. So or critical business and all the other traffic that they use.
As far as I'm aware, I don't think we have any more questions. If we can just go to the next slide so they know how to contact you guys. Fantastic stuff. Yeah, thank you, Sonia and Doug, for providing some fantastic insights. And thank you to everyone for watching. We hope this has been useful.